All right, guys, this is the CR5, the rectangular coordinate system. It's also referred to as the Cartesian coordinate system. It's a standard graphing system for graphing all kinds of equations, functions, and we've got four quadrants. So the um, upper right is the quadrant 1. You see the Roman numeral 1 there. And then quadrant 2, it goes counterclockwise. Quadrant 3, and then quadrant 4 in the bottom right corner. Okay, the origin is right there at the point 0, 0. The x is the horizontal, right or left, the y value. So this is your x, that's your y, right? And it tells you, the x tells you if you're moving right or left, and the y tells you if you're moving up or down. So let's plot a few points here. Let's do this first one, -1, 4. So there's my x, there's my y. Since the x is -1, I'm going to start as if I was at the origin right here at the middle, but I'm going to go left 1 for the -1, and then the y is a +4, so I'm going to go up 4. And there's actually my point, -1, 4. Okay. Let's do the next one, -4, -2. There's my x, there's my y. So I'm going to go left 4, and I'm going to go down 2 from the origin. Left 4, 1, 2, 3, 4, and then I'm going to go down 2. And there's -4, -2. And we should name which quadrant those are in. -1, 4, this one up here, this is in quadrant 2. The red one, -4, -2, this one's in quadrant 3. I remember it's quadrant 1, quadrant 2, quadrant 3 is down here, quadrant 4 is down here. Bottom right? Let's do these other ones. 3, -2, 3, -2. So right 3, down 2. So there's 3, -2. Notice it's in quadrant 4. And let's do 0, -3. So 0 means it does not go right or left, but it does drop down 3. 0, -3. So then the question is it on an axis? It's not, right? It's not considered to be not in any quadrant because it's right on an axis. It's on the y-axis, right? This is our x-axis. That one's our y-axis. All right, let's do this last one, 2, 3. Right 2, up 3. 2, 3 is in quadrant 1. 2, 3. All right. All right, we're going to graph equations initially by plotting points. So let's go ahead and do these first ones. We're going to let x be -2, 0, and 2 for this equation. X minus y equals 1. I like to just make my own little table here, -2, 0, 2. And let's go ahead and let x be -2 first. And we're going to plug it into x minus y equals 1. So if x is -2, replace x with -2 and solve for y. So we've got -y equals 3, divide by -1. So y ends up being -3. So there's our first point, -2 and down 3. Left 2, down 3 from the origin, from the middle. There's our first point. Now we're going to let x be 0. So if we let x be 0 in this equation, 0 minus y equals 1. Well, 0 minus y is just -y. Divide by -1. Y ends up being -1. So we have the point 0. So I do not go right or left, but then I drop down 1. I have the point 0, -1, right? Here's our point, -2, -3. This is the point 0, -1. And finally, let's let x be 2. Subtract 2 both sides, so I have -y equals -1. Divide by -1, so y equals 1. When x is 2, right 2, y is 1, up 1. And now we can go ahead and connect the dots here. Oops, I didn't draw that very good. But that's how you graph a basic linear equation, by plotting points, right? Let's do the same thing for this one. Y equals 5x minus 6. So y equals 5x minus 6. And we're going to let x be 0, 1, and 2. Let's let x be 0 first. 5 times 0 is 0. So I got 0, negative 6 is my first point. 0, negative 6. So I don't go right or left, but then I drop down 6. Now let's let x be 1. So 5 times 1 minus 6. So we got 5 minus 6 is a negative 1. So 1 comma negative 1 right there. And finally, let's let x be 2. So we got 10 minus 6, or 4. So 2 comma 1, 2, 3, 4, up 4. And then we could draw that line as best I can there for y equals 5x minus 6. There's your work for that one. Y equals negative 1, 6, x minus 2. If you plug in negative 6, you get negative 1 first, which I showed down here. So negative 6, negative 1. There's the work for those other ones. So left 6, down 1. And then 0, negative 2. I don't go anywhere right or left, but I drop down 2. And then I go right 6, down 3 on that one. All right, let's have you guys do this one. X plus y equals 4. And I want you to do it for negative 2, 0, and 2. And go ahead and find those ordered pairs and plot them on the graph. There's your work for that one. So you should have the ordered pairs negative 2, 6, 0, 4, and 2, 2 on that one. Then you go ahead, graph those, and draw the line. Let's move on into slope. So if you have a line going up and to the right, that's a positive slope. Right? If it's going down to the left, right, that's a negative slope. If you have a line that's perfectly horizontal, your slope is 0. I'm going to use M. M is for slope. So here, the first one, slope is positive. The second one, the slope is negative. The third one, the slope is 0. And lastly, if the slope is perfectly vertical, and we'll talk about why this is, the slope is undefined. When we talk more about slope, we'll get into that. Let's go ahead and graph this one, and then we'll determine if the slope is negative, positive, 0, or undefined. So y equals 2/3 x, negative 3, 0, and 3. Let's go ahead and plug those into y equals 2/3 times x. Our x here is 3. So we got 2/3 times 3 over 1. 2 times 3 is 6 over 3. It looks like we got 2. So negative 3, left 3, up 2. There's our first one. Left 3, up 2. Let's go ahead and plug in the next one. Y equals 2/3 x, throwing in 0 this time. 0 times anything is 0, so looks like right on the origin, 0, 0. And finally, 2/3 x, we're going to throw in 3. 2/3 times 3 is 6 over 3, or 2. Y equals 2. Oh my gosh, I just realized I made a mistake here. On this first one I was plugging in a negative 3. Sorry about that. That should have been a negative 3. That should have been a negative. Negative 3, negative 2. My apologies. Negative 3, negative 2 was the first one. And then we had the 0, 0 right in the middle. And then at the end we had 3, 1, 2, 3, and up 2. There we go. Sorry about that. And then we say, well, it's going up and to the right. So our slope is positive. Slope is positive. All right, why don't you guys punch those in chat box there. All right, when you plug them in, you guys should get those points. You should see that thing going downhill. In other words, the slope is negative. Slope is less than 0. Slope is negative, going down to the right. All right, the last part of this section is just finding x and y intercepts. Let me give you kind of a crazy looking function for a minute. Let's say you had something like this, and it hit the point -2, 0. It hits the point -4, 0, and it hits the point over here at 3, 0. All of these are what's called x-intercepts because notice they cross the x-axis, right? They're crossing the x-axis. Well, if you notice, all of them have a y value of 0. So when you're finding x-intercepts, you're going to let y be 0. When you're finding x-intercepts, you're going to let y be 0. So I always like to go like this. And I like to make a table. If I'm finding x-intercepts, I let y be 0. Whereas on the other hand, if you're finding y-intercepts, let's say you have a line goes right there and it crosses right there at that y-intercept, that's 0, -3. When you're finding y-intercepts, notice that the x value will be 0. Okay, so if you're finding x-intercepts, let y be 0. When you're finding y-intercepts, when you're finding x-intercepts, let y be 0. So here we go. Y equals -4x plus 4. I'm going to find the x-intercept by letting y be 0. I'm going to add 4x to both sides. So I have 4x equals 4, divide by 4, x equals 1. So when y is 0, x is 1. So here's our x-intercept right there, 1, 0. Now let's find our y-intercept by letting x be 0. So we have y equals -4x plus 4. We're letting x be 0. Well, 0 plus 4 is 4, so 0, 4. 0, 4 is our point, and we can go ahead and graph that line now from those 2 points. Notice the slope is negative going down and to the right, but that's how you find your x-intercept and y-intercept on a graph, okay? Well, appreciate you guys watching. We'll see you next time.